welcome to session 5 of Unit 1. This session will introduce you to the structure of the nucleus. By the end of this session, you should be able to state and explain the structure of the nucleus. Let us now look at the nucleus. The atomic nucleus is found at the center of the atom. It is small in size, very dense, and it consists of protons, neutrons, and has electrons surrounding it. From the diagram here, the circle inside this structure is the nucleus, which consists of protons and neutrons, and we can see electrons around the nucleus. The number of protons and neutrons in the atom define what type of atom or element it is. So an element is a bunch of atoms that all have the same type of atomic structure. For instance, hydrogen is an element. Every hydrogen atom is made up of 1 proton, 0 neutron, and 1 electron, and every hydrogen is peculiar with these features. The number of protons in the nucleus of an atom are referred to as the atomic number. This atomic number is equal to number of electrons in the atom, provided the atom is neutral. The atomic number, which is the same as the proton number, is represented by the letter Z, and it defines which chemical element the nucleus. The number of neutrons in the nucleus is referred to as neutron number, and the neutron number is represented by the letter N. And the sum of the neutron number and the proton number gives us the atomic mass of the atom. So you have the atomic mass, which is represented as A being equal to N, which is the neutron number, plus Z, which is the atomic number. The neutrons and the protons in the nucleus are collectively referred to as nucleon, and this is a typical representation of the atom, where Z is a subscript and A is a superscript. Let us talk about the nucleus. The nucleus of an atom forms its tiny core, which has a radius of about 10,000 to 100,000 smaller than that of the atom itself. Each nucleus contains a certain number of protons and a certain number of neutrons clamped together into a small ball not much larger than the protons and the neutrons themselves. And so, even though the nucleus is a smaller part or just a smaller aspect of the atom, the whole bulk of the atom is concentrated in the nucleus. Let us continue with the content of the nucleus. The nucleus, as we said, is the smallest part of the atom, and it's easy for us to characterize it because it has certain 3 factors that are consistent with it. One of them is that the proton and neutrons in the nucleus differ in mass by only about 1 part in 1,000. So we can conclude that the mass of a proton is equivalent to the mass of a neutron and is equivalent to the mass of the nucleon. Also, the amount of energy required to keep the protons and neutrons together in the nucleus is relatively small. So we can also conclude that the mass of the nucleus is almost equal to the sum of the masses of its nucleons. We established that the protons and the neutrons found in the nucleus of the atom are referred to as nucleons. So the mass of the nucleus is equivalent to the sum of the mass of the nucleon put together. That is the protons and the neutrons put together. The third point is the mass of the electron is 1/1833, as big as the proton. So the mass of the atom is almost entirely in its nucleus. The electron is occupying only a small space by mass in the atom, and so the bulk of the atom is found within the nucleus, and that is the mass of the proton and the neutrons. There is another point that is very important that we should note, that all atoms of a particular isotope of a particular element are identical. All their electrons, protons, and neutrons are identical. So if it's hydrogen, all the isotopes of hydrogen are having electrons, protons, and neutrons that are identical in terms of mass. Their masses are the same. So we can conclude that the mass of a hydrogen is equivalent to the mass of a proton. So hydrogen and proton, which are more or less isotopes, and the mass is the same as the nucleon, or the mass of the nucleon. Another thing to note is that since neutrons are electrically neutral, the electrical charge, which is designated by Q on the nucleus, is just the number of protons times the electrical charge of the protons that are present. So this equation is used to represent that statement, where the electrical charge of the nucleus is given by the proton number times the charge of the proton. Let us look at a typical example of a question on the atomic nucleus. So we have a question which says we should calculate the neutron number of the atom. This is thorium, with mass number of 231 and atomic number of 90. Now we are to calculate the number of neutrons, but we know that the mass number is given by neutron number plus atomic number, which means that if we can solve for neutron number from this equation, we have answered the question. So you substitute the values for mass number and atomic number into the equation and solve for n to give a neutron number of 141, which means that thorium has a neutron number of 141. Another example is the question 2 here, which says how many protons and neutrons are present in an atom. This is argon with mass number 40 and proton number 18. So in this question, the proton number has already been given, which is 18, so we just state it. And we have to find a neutron number, but we know that mass number is given by neutron number plus atomic number. So we solve for atomic number by making n the subject here, and we get a neutron number of 22. So here is a self-assessment question, very interesting question for you to solve. So you complete the table by providing the missing values. In this session, we looked at the atomic nucleus, where we said the nucleus is found at the center of the atom and it is very small in size. It contains the protons and the neutrons, which form the bulk of the atom. That is, the entire mass of the atom is located within the nucleus. We looked at electrons as particles that are found outside the nucleus and are moving around the nucleus.